So the idea in section 4.4 is to do arithmetic using our normal kinds of ways of doing things, but to do them in different bases. And one of the keys to remember is when you're writing down stuff in this kind of problem, everything that you write down here should be a base 2 number. Base 2 numbers can only use these two digits. And so, for instance, if I were to have a 1, 1 in base 2, that would be 1, 2 plus 1, 1, and that would be 3. So 1, 1 is 3. This would be 7, because it'd be a 4 plus a 2 plus a 1. This would be 5, because it would be a 1, 4 plus no 2s plus 1, 1. And so you can get used to some of these numbers by just trying things out. So here we go. We're going to have 0 plus 1, and that's 1. But the way to write 1 in base 2 is just 1. Then we do a 1 plus 1, and a 1 plus 1's 2, but we can't write down a 2 in base 2. Base 2 doesn't let us use 2's. So what is a 2 in base 2? Well, it has one of these 2's and 0 of these 1's. And so 1 plus 1 in base 2 is 1, 0. It's kind of like a 10, but it's a 1, 0. So we put the 0 down here, and we carry the 1, and now we have a 1 plus a 1 plus a 1. And that's 3. But we can't put a 3 down here. This is for base 2 results. And so how do we get a 3? Well, we have a 1 of these 2's and 1 of these 1's. So a 1, 1 in base 2 equals 3. And so what we need is a 1, carry the 1, and we know that this is 3, and that's 1, 1. So we have that these two numbers added together in base 2 equals this base 2 number. Now each of these problems in this section can be checked, and you should check them. You can turn each of these three numbers into base 10 and then add the base 10 numbers and see if they work. So let's try that. I'm going to extend this one more, and then I'm going to put the first number in. And so what is this number in base 2? It's 1, 1, 1, 0, but what is it in base 10? Well, it's an 8 plus a 4 plus a 2 plus a nothing. 8 plus 2 is 10 plus 4 is 14, so this is the number 14. What about this number, 1, 1, 1, 1 in base 2? Well, it's an 8, a 4, a 2, and a 1. That's going to be 15. And we know that when we add those, we get 29, but the question is, does this answer number equal 29? Well, it's a 16 plus an 8 plus a 4 plus a 1. 4 and 16 is 20, 8 and 1 is 9, so this is 29. So this number is 29, this number is 15, this number is 14, and 14 plus 15 equals 29. So we've checked our work. On an exam, do this in the base that you're given, but then also convert them over to base 10 and check your work that way. In base 12, we have these digits, 0 through 9, and then A and B. And so let's go ahead and start. So we're going to have 3 plus A, but A is 10, so this is going to be 13. This is a 3 plus a 10, and it's going to be 13. But how do we write a 13 in base 12? Well, these are 1s, these are 12s. How do we get a 13? Well, it's with a 1, 1, isn't it? Isn't 1 12 plus 1, 1, 13? So we're going to put down a 1, and we're going to carry a 1, and this is 16. So how do we get a 16 in base 12? Well, it's one of these 12s and 4 of these 1s. That'll be 16. So we put down a 4, and we carry a 1, and that's 1 plus 2 plus 8, that's 11. But 11 is just a B. And then we have B plus 4, that's a 15 again. But a 15, well, I haven't done 15 actually. would be one of these and three of these, and so we have this result. You should check these by converting each of these to base 10 and then see that this base 10 number plus this one adds up to this one. I'm going to let you do the check on your own. Subtraction's kind of sneaky, so we're trying to take away a 2 from a 0 and we can't do that. So we're going to come over here and borrow 1. If this was base 10, we'd borrow 1 from this 10 and we'll put a 1 here by the 0 and a 9 over here. But this 1 0 is not 10. 1 0 is a 3 and no 1s. This is 3. So if we borrow 1 from it, what we're going to get here is a 2, and then the 1 that we borrowed is going to go over here, and this is going to be a 0. And so what used to be 1 0 0 now looks like 0 2 and then 1 0, which is fairly strange. Let's see what happens. So now we have a 1 0, that's 3, take away 2, that's 1. We have a 2, take away a 1, that's 1. We have 0, take away 0, and 2, take away 1. So we think that we're getting this answer, 1 0 1 1 base 3. But that is very, 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 very strange. And maybe that wasn't even enough varies. So let's translate these into base 10 to check our work and see if we did it right. So we're going to have 2 1 0 0. That's 54 plus 9, that's 63. And then we're going to have 1 0 1 2, that's 27. Plus 3 plus 2, that's 32. And we're going to subtract, and we get this, which is 27 plus 3 plus 1, which is 31. And lo and behold, this subtraction looks correct. So we borrowed our way to a correct answer. So we can't do 4 taken away from 3, so we got to borrow 1 from this. And that will make this be an A. And we put the 1 here. Now that's not a 13, it's a 1 3. And a 1 3 is 12 plus 3 1s, that's 15. So this is 15, take away 4. 15 take away 4 is 11. And 11 is B. That's quite a bit of thinking. We can't really do A take away B, so we borrow 1 from here and put it here. Now we have 1A. And what is 1A? Well, it's 12 plus 10, that's 22. So this 1A is 22, and we're taking away a B, which is 11. So it's 1A take away B. It's 22 take away 11 is 11, and 11's B. Fairly weird. 2 take away 1 is 1. Thank goodness for small favors. A is 10. 10 take away 2 is 8. So it looks like when we do this subtraction, we are getting 8 1 B B base 12. I'm going to leave it up to you to turn this into base 10, this into base 10, this into base 10, and check the subtractions. 2 times 3 is 6, but 6 in base 6 is 1 0. 3 times 1 is 3, plus 1 is 4, 4 is 4. We got 3 times 5 is 15, but in base 6, 15 would be 2 of these and 3 of these. We move over 1, 2 times 2 is 4, 2 times 1 is 2, 2 times 5 is 10, but 10 in base 6 is 1 6 and 4 1s. 4, this is 0, 4 and 4 is 8, but 8 in base 6 is 1 2. 1 plus 2 plus 3 is 6, but 6 is 1 0. 1 plus 2 plus 4 is 7, but 7 is 1 1, and 1 plus 1 is 2. So I think that the product of these two numbers in base 6 gives us 2 1 0 to 0 in base 6. And if you turn this into base 10 and this into base 10 and multiply, you should get this number in base 10. I'll leave you to check. What about division? Well, 4 doesn't go into 2, but it does go into 2, 5. Notice this isn't 25. 4 would go into 25 6 times, but it's not a 25, it's a base 8 thing. So what is 2, 5 in base 8? Well, it's 2 8s, that's 16, plus 5 1s. So that's 21, so this is really 4 into 21, and that goes in 5 times. 5 times 4 is 20, but how do you write 20 in base 8? Well, it's 2 of these 8s plus 4 of these 1s. And so division's a little harder than you might guess. So now we have 4, and it seems like it would be simple. You know, we have a 1 here when we subtract, and we bring down the 2, and 4 obviously goes into 12 3 times, but no, stop. This is not a 12. Everything that's written in this problem is in base 8. Things you think might be in base 10, but things you write are in base 8. And so, what is 1, 2 in base 8? Well, it's 1 of these 8s and 2 of these 1s. This is actually 10. And 4 only goes into 10 twice. And 2 times 4 is 8. But we've got to write 8 in base 10 and we've got to write 8 in base 8. And that'll be 1 8 and 0 1s. And we subtract and we get 2. And so we have that 4 goes into 2 5 2, 5 2 times with the remainder of 2, all in base 8. And again, if you wanted to check these, you could by simply turning every single one of these numbers into base 10. And these two really are already in base 10. And then checking and see if the division actually works. And it does.